Okay, this is section 2.3. We're asked to find the domain of the function. Anytime you're looking for domain, this is the values that x can be. And just to start off, we'll just assume that x is a real number. And then we'll make some caveats after that. Also, you might recall if we've got something like 5 over 0, this is an undefined fraction because we can't have 0 on the bottom. We can't divide by 0. So basically, we've got to make sure, no matter what x is, that the bottom, this x minus 14, the denominator, cannot be 0. The denominator cannot be 0. So we just set that up just the way that we've written that there, x minus 14. And the cannot be equal to, we put equals with a line through it, cannot be equal to 0. And then you just solve it like you normally would in algebra problem, trying to get x by itself. So add 14. That gets rid of the 14s there, and we're left with x on the left. Bring down the unequal sign, x not equal to 14. So now we know x is a real number, and I'll go back up to the top here, but x cannot be equal to 14. And this would actually be the solution that you'd click on the answer. Okay, for a second example, we'll go ahead and do one that's just a little bit more involved, but not much more complicated at all. So we've got a function called g of x is equal to 10 over 4 minus 5x. And the same thing as with number 1 is true. We've got to make sure that the denominator is not equal to 0. So we start out with x such that x is a real number. Okay, and then we'll just make sure that this denominator cannot be 0. Like I said before, that would make that fraction or that function undefined. So we'll just say 4 minus 5x cannot be equal to 0. Then just go through your steps. We want to get the x by itself, so I'll start by getting rid of this 4. So we got negative 5x cannot be equal to negative 4. And then we're going to get the x by itself a little bit further. We've got to divide by the thing that's in front of x. So divide by negative 5 on both sides. The negative 5s, you can think of it as canceling each other out, or you can think of it as 1 in front of x. So x is not equal to, if you got a negative over a negative, that just becomes positive. So we've got 4 over 5. X cannot be 4 over 5. So back up top, x is a real number, but x cannot be equal to 4 over 5. And the only other thing to mention in section 2.3 is that if you don't have a denominator, you're safe to assume that there's no restrictions on x and that just x is just a real number. So if we've got something like p of x is equal to 2x minus 8, you could just say there's no denominator. So x such that x is a real number is all you'll need. There's not going to be any values that x cannot be. Also, if you have something like p of x is equal to x squared plus 3, the same thing applies.